Now, Gavin's come from the University of Sheffield, and they are their Advanced Manufacturing Research Centre, the AMRC. And so Gavin is going to introduce lots of cool tech in construction to us. So over to you.
All right, folks. I had a really long title, but then I got really bored of it, so I made it different. So I just said, look, I want to talk to you about cool stuff going on. And to be honest, I was actually, in kind of the interactions that I've had with Stuart and bits and pieces, I was expecting to come down and talk to what I suppose is the stereotypical construction audience. And I was expecting to talk about some stuff, and you kind of go, oh, look at that. Look at that, and then I'd get a bit of an ego hit, and it'd all be great. But fundamentally, everyone here really seems to kind of get this. You seem to be the people who are already interested in innovation and really trying to drive it forward, and that is really inspiring. If I was to talk to you guys even 5 years ago, I think that this room would be a little bit different. I also think that when I talk to the more stereotypical people that I do tend to talk to in construction, they probably have a little bit more of a closed mindset than what I've seen. So I'm going to go through the same presentation, but I'm going to try to tweak it a little bit. I'm going to try to talk about things in a slightly different way, all right? Just before all that, just to explain what we are and how I've come to be here. So from the Advanced Manufacturing Research Centre, which is part of the High Volume Manufacturing Catapult, and there's a load of our centres across the UK. All that means, realistically, and the bit that I want to get out at the start with, is that about a third of our funding, about a third of what I do is government funded. So that means about a third of what I do should be just generally helpful. So if you've got a question, you're like, how do I do this thing? At least 1 in 3 times you ask me, I should give you an answer without there being anything attached to that. And it's also really nice because I don't have to sell anything anymore. It's a lovely, lovely space to be in. But it the reason that I'm highlighting that is just from some of the stuff that we spoke about earlier on. You're talking about innovation. How do you do innovation? And it's really hard, right? There's cultural aspects, there's bits that you have to do there. But there's also this bit, and we had a bit of a discussion around lunch on it as well, there's this bit where I'm going to say construction doesn't necessarily get the best conduit for funding innovation from the government. You have other industries where they're just a bit better at, or maybe more established, or maybe the industry lends itself better to it. But if I was to talk about my main work, most of my work's in aerospace. We've got a lot of growing areas in construction. We do rail, we do automotive and medical, but they've got a lot of those areas are just different and more easily approachable funding streams to help support innovation. And I think that makes a difference in the mindset as well, because if the government fund it, then you kind of feel all right about doing it in the first place. It doesn't kill your margins, and it means that you're actually required to talk about it to people. You have to disseminate it. So it's a completely different sort of mindset in those companies to what we've spoken about earlier on, where a company in construction will do innovation, but they'll close the doors really heavily on it, and you'll never know what happened. And there'll be like some technology provider, I'm sure the UAV guys will be there, where they'll talk to like one company and they'll go, we've got this really secret project. We want to do this. It's going to game change everything. And you're like, yeah, cool. Do that. Next day, their exact competitor will be doing the same thing. We've got this really secret project. And it just, it's not conducive to helpful. So just saying we're there. There's loads of us, loads of different parts of the network, and we're available to help, or at least we should be. But because I've only got so much time, I'm not going to hammer on about everything that we do, but I'm just going to show you some of our buildings because it gives you an idea of what we get up to. Our training centre works with apprentices, so we've had about over 1,700 apprentices come through the doors there since 2014 when it opened. They're not all finished, but it means that we're helping to, bring young people through mainly into an awful lot of different industries. And we say Advanced Manufacturing Research Centre, manufacturing is really broad there. If you make a thing, if you assemble a thing, or you're connected to that area, we'll probably classify you as a manufacturer. So that's why construction counts in my mind. But that provides one route. We've then got an awful lot of smart people knocking about in areas like the design space, in composites, in machining of materials. We've got nuclear AMRC as well, that kind of do a lot with some of like large infrastructure projects like Sellafield, etc., which very highly aligns. And then I spend most of my time in this circular building here, which just, I'm sure you guys appreciate this more than most. A circular building, terrible idea. Try fit a kitchen in there. Genuinely, it's horrible. Really lovely, like aesthetically beautiful though, I have to say. But we do all of our work around digital manufacturing there. So Industry 4, if you heard that sort of term, you guys in this world tend to talk about a golden thread. We tend to talk about a digital thread. We've heard digital twin thrown around a lot over the last kind of while, but it's that sort of work is where I spend my time. So I look after a team of about 20 people who are all software developers, data analysts, just generally smart people who are all supporting this area and doing everything from AR and VR across to looking how IoT aspects come through to smart building. And I'm going to take you through some of that in the context of construction in a minute. The only other one just to say is we've also got, there's an iCare building over here, which is one of the university buildings, which is just heavily aligned to structural and civil engineering, as you might guess. But it means that we've got literally that's about a 50-metre walk to talk to some of our colleagues in the really academic space who are looking at developing in that world. And we sit in this realm, so that's why I say academics when I'm talking about the others. We sit in this kind of space, and people are familiar with the technology readiness levels. It's basically really good ideas come from academia, but it's usually got a wire hanging out of it, or it works 1 in 7 times or whatever. And most of the time, if you take that and try and drop it into industry, it's just never going to happen. But if you give an idea that's pretty well proven out in a specific environment, but you just need to change that environment, then industry can crack on with that. So we tend to sit in that bit in the middle that kind of takes it across from one to the other. And that, for me, is the fun space. There's a load of companies down here that we work with. So we run a membership operation, and we also work with loads of others. But it just, if you're wondering what those random symbols are, it just shows our kind of reach into the industrial space. And then, similarly to, there's loads of bits, loads of crossover to chats from earlier on as well. The Nifty Lift Gen was talking about the circular economy, the life cycle. And we tend to have capability in just about all of those areas. So this goes from design concept, and it fits in with the buildings that you've seen, but through manufacture, through in-service, what's going on. We talked about the LoRaWAN stuff, like getting information from buildings as they exist at the moment. How do we get that data? What do we do with it? How do we correlate it with other information? I had a really nice chat with people down at the coffee machine there. Turns out there's at least 3 companies in the room who get data from their coffee machines to work out how many people are using that coffee machine, when they're using it, when it's running out of beans, how much energy is being used off of it. And although that seems trivial, if you start thinking about doing that sort of analysis on loads of machines that you have around your facility that maybe are a little bit more important to your business, it becomes really interesting space, and that fits in with a lot of the stuff that people have talked about asset monitoring and stuff as well. But that's enough preamble. I went really deep on the preamble. I'm not going to lie, I did not think I was going to spend that long. But I'm going to talk to you about just a couple of what I think are quite cool bits. And as I say, I was not really sure of the crowd fully, so I need to take this in a slightly different vein. Some of these will be quite interesting to you. Some of them might be a little bit, I've seen that before. But this is probably a snapshot of projects that we've done in the construction space across maybe about the last 5 years. So some of them are really quite new, some of them are a little bit older, but they kind of show different ranges of technology. So everything from stuff that's really affordable and I could do today to, right, that's crazy, mental, we're not doing that for a while. And hopefully it's just going to create a bit of a conversation and line up with a lot of stuff that you've heard as well, which is really nice. So I'll talk about the kind of technology that goes into it, the use case for it, and then some of the benefits, but I'm sure you'll kind of make up that benefit piece yourself. So the first one's smart set, and also I should say, all of these, I'm pretty sure all of them, all have an associated company with them. So yeah, again, I'm not speaking from a pure academic side because I'm not very smart, so I can't. But we solve problems that exist that actual customers have, actual people have. So we work with organizations to do that. So all of these have an associated customer. So this one we did with Lang O'Rourke. And this was about us trying to work out how do we get really simple technology onto a site? How do we go away from that idea of Oh, you want to do Industry 4, do you? That's probably about like £6 million just to look at. Can we show people those little bits of innovation that you can do? And I think it was touched on earlier on as well about just doing innovation. This is one of those bits where it's like, right, I can just chuck a couple of grand at that, or a small amount of money, and we can see what we get out of it. And that de-risks the next involvement, the next type of innovation you want to push through to your boss or the business. Also, I have to apologise, there's a couple of drawings in here, and I just should have got the exact specifically right ones, but instead I just took what I could get from Google with free access rights. This is a representation of just any old drawing that you have, stuff for like first and second fix of electrics or plumbing. Obviously that isn't, but it's to represent it, and we'll see in a second. Essentially, most of the time, if you go on site, that's what you've got, right? If you're going to do first and second fix, you've got a piece of paper, or you might have a tablet if you're lucky. You might have a different view on that, but you're fundamentally looking at it and then going, right, let's get over to this wall and see what we can do. And you make your measurements and you hope you kind of get things right, but there's always going to be a bit that's off slightly to one side or slightly to the other side, or because the person before you has decided to put a soil pipe slightly to the right of where you were expecting. That means you have to put your socket slightly to the right of where it was expecting, and it messes up your BIM model, it messes up everything that goes with it. So this was just using really simple projection technology, and there's much smarter projection technology, but using really simple projection technology to try and address that problem. So this is just a little bit of a video that's kind of showing, yeah, right, standard enough, I've got a piece of paper, I'm trying to set things up. But can we do that in a slightly different way? It's really simple. It's a projector, and it's pointing out where you need to put stuff on a wall. The bit where it starts becoming useful and like a bit more dynamic is that these systems now have an awful lot of smart calibration involved with them. So you can set them off and go, right, there's top left corner, there's bottom right, and it doesn't matter if you budge into it, it will recalibrate itself to know where it needs to be. Or obviously, if you're standing in front of it, you're not going to be able to see much. So you can move it to the side and it will put that throw to the right place again. But just an example of quite a useful piece. We took this on site. You can see that's pretty fundamental. It's very broad or simple base. We took that on site as a projector on a sack truck. Like, that's pretty much what it was. But we took it down, and basically they didn't want us to take it back from site. Really useful piece of kit. Really simple way of using innovation. That's that one. The second one, we spoke about, so a couple of people spoke about kind of XR and VR and AR earlier on. This is a project from a little while back, which is kind of going, well, how do we use AR or mixed reality in the construction space? This was around electrical cabinets. So yeah, again with Langer O'Rourke, but creation of electrical cabinets, once you've created them, you need to, if there's an off-site creation, even on-site actually, you need to test it. Right, and the traditional way of doing that is you look at a diagram like that, you put a multimeter on, you probably get it wrong, you write it down somewhere, and then you transfer that to like an Excel sheet or something later on. In this case, we used a Microsoft HoloLens, so a wearable device with a Bluetooth multimeter, so that it can automatically connect across. And you'll see in a second how this works, but essentially, you would log in. So this is what the operator is seeing through their AR lens. They're logging in. They're doing a quick visual inspection to go, right, does it look like the main components are where they should be? And then you're getting told essentially, what operations do I have to do? How do I measure what's going on? So it highlights each one of the modules that I need to connect to. You can't see it just off to the side here, but because this is Bluetooth enabled, it's giving us a live feed of what I'm getting from the multimeter. So it can tell me stuff like, oh, well, that should be in the range of 10 to 15 amps, but it's not. It can immediately alert you to that, and you can kind of think, oh, have I actually put the probe in the right place? You can recheck that, so you can check your errors before you get too far into it. Interestingly, you can see, right, like that's not a perfect overlay. So this was with HoloLens 1 from a couple of years ago. And Microsoft said to us, they're like, you can't get that accurate. You won't be able to get down to the terminal level. So we went, yeah, fair enough. So over here, you can see there's some red bits highlighted. And it just means we've got another visual that says, right, that's the terminal block. You can see where that is. But this is telling you, the red dots are telling you where exactly to put your probes. Since then, HoloLens 2 has come out. There's been loads of innovation. You can get much more accurate now. You'd be able to do that without too much of a worry. But massive savings on the time it takes just to go through all of that. Massive savings on the amount of errors coming through, and just humans. Humans aren't make mistakes, but if you all made the full process, it makes it a little bit easier. So I didn't say it there, but one thing you can do with that is just basically once you made the connection, you can just say record, and it'll record that value and just pull it through. So yeah, again, then we've got our traceability sorted as well. Next one up is a Ropke. It just rolls off the tongue, that one. And this one, yeah, I didn't realise, but I put in so many Laing O'Rourke things at the front end of this. But I suppose that says a little bit as well. We've got a good connection with Laing O'Rourke, and to be fair to them, they're quite an innovative organisation as well. This one is around just basically the forming and the rebar that goes in the fixturing for precast concrete. And it's just pretty simply going, how can we make sure that when we actually pour the concrete in there, we've not put something in the wrong place or we've not forgot something? Because concrete sucks to try and take apart again. So it's all about avoiding rework. So it's really simple. The approach to it is just relatively simple in the grand scheme of things. Put a camera up. So the other thing is, bearing in mind this was specifically for us talking to them about off-site build. So where they were doing a lot of this, in a facility, the same logic would still work on site, but you need to be a little bit smarter. You need to put a little bit more logic into it. But you put a camera on, you use a bit of machine learning, and you can work out what's going on. So fundamentally, create a bit of software. It looks down. I can't show you all of this because there's a bit of IP behind it that I can't share, but it would look down. There's a lot of stuff going on here, but it's effectively looking for every one of these. It's making sure that everything's in there and in the right place, and it is alerting you if it's not. Very simple, but it means you don't make mistakes. And yet again, you have traceability again. So if something does go wrong in 4 years' time, you can go, it wasn't us. And that's kind of a really nice space to be in. But that one is relatively simplistic, but it just has a big impact. Next one, what time was it? I did great, actually. Next one up is probably my favorite out of what we've got here. And it's Project DAX. Now, this one hopefully is going to end up being productized over the next little while. And it was work we did with Loop Technology, and I'm sure I've written it down. Eurovia, there we go. So it's about paving. So, how often do you go out, just walk down any high street and someone's got a console out and there's about 15 people around them trying to suppress, the dust coming up. There's someone else there just making sure that all the health and safety went to as it should do. And there's loads of the public coming over going, could you be a bit quieter, please? That's a problem. It's fundamentally a problem, right? We come out and we go, yeah, well, if we're doing paving, we're going to do it here. Why are we doing it here? Why are we doing it on site? That is a bonkers thought, but we've always just done it. So this is a bit of a project and went, right, can we do it a different way? So essentially we used a bit of scanning and a bit of robotics and some smart kind of digital strands in behind to enable this. So what happens is you get that's actually a LiDAR scanner, but when we started with LiDAR scanner, some of the new iPads actually have some depth capability on them. So they can do depth calculations for us. So we're able to do this with an iPad. By basically you coming along and going, right, we've done most of the paving, but we have to get around that lamppost and there's an edge there and there's a bit missing. You come along and you scan that bit that you haven't done. So scan that through, creates a map. That map gets turned into essentially jigsaw pieces of the types of paving that you need to put in place. And interestingly, it saves a lot of stuff like waste as well, because we can get an inventory of all of the bricks that we do, or all the paving stones that we do have. We can also say, right, if it's a third of a paving stone or more, we're going to hold on to that as inventory, and I can use that for the small bit later on, rather than it just getting chucked at the end. So it means we cut down on that. Create those jigsaw pieces. Then in this case, we've used a robot for this. I'll explain some of the pros and cons of that in a minute. But we use a robot to cut out our paving stones, and it also marks on them with a bit of a scanner. It puts on potentially prints a label on them to say that's piece 4 is going to go in that hole. We then chuck that onto a lorry or wherever, bring it out on site, and then it's fundamentally just dropping it down. So there's some videos that explain that, which keeps me, makes it a little bit easier for me, and also so much easier to understand when you can actually see it. So I'll let this play through. But you can see we're getting that scan, we're looking at how we would position that, and then we're getting a robot to mill that out. In this case, we're just showing it in foam because that's what the video is, but we did definitely do this with stone, and we've done it in numerous different ways. There's a reason that you don't see cutting bits like that used to cut stone very often. You always see a blade. Yeah, one of the main reasons for it is on occasion, if you give it another like 2 or 3 seconds, you start making lava. So like we destroyed so many tool bits by doing this, and just like basically there's carnage in there. And what I wanted to really do is just go, look, innovation, yeah, there's really cool stuff in here. We've shown a load of wins, everything goes well. You have to fail a couple of times before you get there. So that's normal for us. Like something goes wrong, you're like, all right, okay, yeah, well, we'll learn from it. And I think that was mentioned earlier on as well. So we learn from it, we move forward. But yeah, we got to learn some stuff there. One is, yeah, if you need to make a curve, it is kind of nice having that robotic element. You can kind of get around stuff a little bit better. But if you can do 99% of your paving with just a straight cut and a bit of water on there, makes a hell of a difference. And then, yeah, this is just the demonstrator piece for when we did that demonstration, just of how that came together. But as I say, hopefully that's going to be something that'll be productized relatively soon. And you can, I think it's pretty obvious, like anyone can kind of get that one. And then the last one I have up, which I'm like well ahead of time, which is good for me, is just a really simple application. So, I know you can go out and you can buy really large bore drainage pipe in kind of standard sizes for things like that. But how often do you end up like doing a big piece of work and you're like, right, well, I'm going to need 4 different pipes to come into that. They're all different diameters. They're all coming in at 72.6 degrees. But that one's offset by 5 inches and 4 millimeters because somehow we've mixed 2 types of drawing at the same time. If it's anything custom, you end up having a person. You have a person comes in, and that's what happens. So you get a person in. So this was all with Polypipe. They've just changed their name actually, or their owning group. I can't remember what they're called, but someone comes in and they mark out in chalk the hole they need to make, and then they saw that out. And it's just really awkward because it's 3D profile, and you're trying to put basically an ellipse on it. So fundamental job, but it's really damn hard. And this is a perfect little operation for a simple robotic automation process. So this is very simply just a robot doing that job now. So this took the average times, yeah, it'll show it in a minute, but average times it took down from about 45 minutes to 2, something like that. By the time as long as you've got it fixtured, I think that's the caveat. But it just makes things so much easier and so much more accurate, so much more repeatable. You end up, tolerances aren't hugely important on this, but it's nice when things do fit roughly. And this is just, as I say, a way in which you can do that. So that's actually it for me. I had about 100 different points and comments from earlier on because there's been really cool stuff spoken about and so many things that resonate with what we get up to and just what I'm interested in. So I'm very much looking forward to the panel side of things and just talking through stuff at that point. But I'm also appreciative of this being the second day, otherwise known as the last day, and it being 10 to 4. So I won't hammer on too much more about anything else, but yeah, we'll just jump into the panel.